Working on a 2006 Mazda 6 with the 2.3 inline 4 non-turbocharged engine. Having issues with the variable intake air solenoid valve. So let me grab the scan tool quick. I got key on, engine off. So if you look here at this wiring diagram, you got the variable intake solenoid valve, which I'm having issues with. And then the variable tumble solenoid valve is good. I'm just using that as a comparison. It's good. What feeds these is you have 12 volts coming from the fuse box. The computer controls the ground, 2I and 2J, the terminals there through a transistor. And I believe the transistor is bad in this, and I'll show you why. So first we're going to check we should have 12 volts going to these white wires, and the control side wires, the blue and the orange and the green and the red tracer will have the test light should turn on when you control with the scan tool. So if you come over here, I'm in active test in the scan tool. I go to intake manifold runner control. That's good. Intake air shutter is good. And the intake manifold tuning valve is bad. I'm using these for comparison. They're good. So I hit that. I go to active test. I don't need any live data. Open it up. Before I do that, I'm going to take my test light, hook it to battery positive or battery negative. And then I'm going to prove that my test light works here. It should light up, which it does. And if you remember on the wiring diagram, the white wires were my 12 volt positive. So I should have light up there, good. And the white wire here lights up good. Means I got wire or power feeding them. So I'm going to take my test light, go to battery negative now. Obviously I just reversed the polarity, still works. So if I go to the intake manifold runner control, which is this one, a good one. I'm not piercing, I'm just touching the tip there, no light, but if I turn it on, the test light comes on. If I turn it off, the test light goes off. We know that circuit's good. Let's back out on the scan tool. Come over here. Intake manifold tuning valve is the suspected bad one. I don't need live data. So you did notice, I don't know if you noticed or not, but the one we just did is normally off. The one we're doing now is normally on. So if I go to the control wire over here, which is the top one, not lit up, but it should be lit up because it should be going to the ground. Even just to turn it off and on, it doesn't do nothing. So just so you know, I checked the resistance across these. I got like 40 ohms on each one. The circuit's good. I can control it with a power probe. It's good. And then I went through the wiring diagrams just for history. Connector C08, which is under this fuse box here. If you look, the green and red, and then the green and red, I checked all that up to the PCM and it was all good to go. So now, and just so you know, connector 308, or connector C08 is under this box right here. So then what I did is, if you look at this circuit, we have 12 volts going up to here, and the computer controls the ground through transistor 2J. And 2J is on the pin out of the computer, which I'm going to show you over here. But before I hook that up, I'm going to hook my test light. And this lead right here is going to my multimeter ground side. I'm just going to battery ground. I got these unplugged. I'm going to come over here. So I'm going to the intake manifold runner control. And if you look here, I'm going to go to bidirectional test or active test. I don't want no live data. So this solenoid is normally off. I got my multimeter. I'm going to go to the transistor that controls it, which is, let me find it here. This one right there. And I'm probing, let me find it there, in that transistor, the control side. And I have no voltage, which I would not because this one's normally off. If I turn it on with the scan tool, now the scan tool is telling it to turn on. Let me go back and probe that same exact circuit. The control side for the transistor Well, I should have 4.5, 5 volts. What should I do? 4.5 volts there, 5 volt, which is turn it on. I go to the base side or the control side, which is back here. Going to there, that's the 2I pin. That's just making a ground. Should have no voltage, just going to the ground. That one's good. If I go back to the scan tool and I back out, I go to the known bad one. The intake, I don't need live data. This one's going to be normally on, so it's opposite. So you'd expect 4.5, 5 volts on the control side, which is this transistor right here. Go to that test little port there. You can see that. It's the control side. I got 5 volts. Problem is I have 5 volts going on the ground side. Or 4.4 actually drop, which goes to pin 2J, which I'm not supposed to have. But if I go turn it off, which it's off, you would not expect a 5 volt reference on the control side for that transistor. Let me get back to that pin. I'm back to it. So the computer's not turning it on because we told it to turn it off, and on the control side, not the control side, the ground side, same thing, it's good. So that transistor is internally shorted on the gate side from there to there. To prove that, if I go up here to this other transistor, it's the one like we just tested. If I go to the control side, I have 5 volts. But I go to the base side, which go to the solenoid, different solenoid, I should have no voltage, and I don't, unlike the other one like we did. Now, if you go back up to this engine bay up here, and I grab my multimeter and I bring it up there, just to prove that, hang on. Bring the multimeter up here. You see that screen there? And I probe the control side. I have 0 volts on the good one, and then the bad one I should have 0 volts as well. But look, I got 4.4 volts because that transistors are internally shorted, so it needs a new transistor soldered in.